Hello, class. This will be a recorded lecture for section 8.3, and this deals with determinants of matrices. What I would recommend doing is actually looking at 8.4 first and then doing 8.3. And so that's kind of how I structured this lecture, because the idea of determinants is a very specialized calculation for matrices. And so I think it's better for you to get a general view of matrices, how to add, subtract, multiply matrices before you do determinants. But I didn't write the book, so they put this one first. So the idea of a determinant, we are again going to kind of put it in the concept of solving the systems of linear equations. And the calculation of determinant gives this calculation of a single number. So again, when you calculate a determinant, one of the criteria is that the matrix needs to be square. And so what we're going to do, and we introduced this idea of square matrices in section 8.4, that's why I said it's a little bit weird. And they really don't say that in this section. So with regard to the calculation, we're going to take a look at a determinant with a 2x2 matrix and a 3x3 matrix. And that's far as we're going to go. And the idea is that we're going to use these determinants to solve a system of linear equations, use something called Cramers rule, a mathematician that came up with this idea and concept. And I find it to be useful when the numbers are weird. And what I mean by weird numbers, if you end up with a bunch of fractions, because this is a nice systematic way of calculating numbers, and the fractions will fall right out. And I'll show you what I mean, obviously, when we get to that. So let's get started and jump right into this here. And so we're going to start by evaluating what we call a 2x2 determinant. And so again, the matrix is 2x2, and out comes an answer. And it's really kind of a reasonably simple calculation, I hope, at least with the 2x2, once you get the hang of it. And the idea is a determinant's always a single number, which is also really nice. And so the idea of a determinant here, and here's the definition, is that if you take a 2x2 matrix and calculate the determinant, you multiply the diagonal, which would be A times D, and then you multiply the up diagonal here, which is C and B, and you subtract those two numbers. And so let's do a couple examples. So let's do this one here, and we'll do this one right up here on the whiteboard. And so if you have a matrix that is 2x2, it would be 3, 6, minus 2, and 1. And when you put these straight lines, that implies you're doing a determinant. And so the strategy is such that you take the main diagonal, that's what this is called in the matrix. And so that would be 3 times 1. And what you do is you subtract it from this diagonal. And so that would be minus 6 times minus 2. So again, once you have that set up, it's kind of nice because basically you just do a little bit of arithmetic. 3 times 1 is 3. And what that would be is minus and a minus, so that would be plus 12. And so you would get the number 15. Let's do one more. So say like we had 5, 4, 3, and 2. Just pick some numbers up. So again, if we do this diagonal first, and so that would be 5 times 2, and then you subtract the off diagonal, that would be this here, and so that would be 3 times 4. So when you do that, you would get 10 minus 12, and so in this case, it would be minus 2. So you can get any number with regards to this, and you could even get 0 if it's set up such as you would have, say, 2 and 4 and 2 and 4. So if you set it up that way, you would see that would be 8 minus 8, and so you would get a determinant of 0. So 0 is a fine number with regards to a determinant. Okay, so one of the things that we can do with these determinants now is solve a system of linear equations using what's called Cramers rule. And Cramers rule is based on the calculation of determinants. And you can also use determinants to calculate inverses as well. We talked about inverses in section 8.4, but there are other ways to do it using determinants as well. And so here's the Cramers rule. And so this is on slide 8, and this would be a handy slide. And I don't expect you to memorize this, but it is be quite useful when you walk through this homework. And so the idea is that you set the equation up in a matrix format where the coefficient matrix is the coefficients on the variables. And what I like to call the answer matrix is what's on the left side or the right side of the equal sign. That's the S and T in this case. And you could see by finding determinants, you get the exact answer for X and the exact answer for Y. So the main determinant is this D, which is the determinant of the coefficients. And that always goes in the numerator. And what goes in the denominator, What goes in the numerator is that if you calculate the X, you replace the X column with the answers. And if you are calculating Y, you replace the Y column with the 2 answers and calculate the determinant and put it on the top or the numerator. Again, because I said it incorrectly, the main determinant goes in the denominator, and the X and Y determinant goes in the numerator. And you can see it gives you the fraction right there, which is really, really nice. And it makes it so much easier not to make a arithmetic mistake doing calculations when there's a bunch of fractions. And so let's solve this particular example. And so this example is 3x plus 4y equals 1, and 7x, minus 5y equals 31. And so the idea is what we call this D determinant, is the coefficients from the variables. So that would be X variable is 3 and 7, and this one is 4 and minus 5. So if you wanted to calculate that determinant, it would be 3 times minus 5 minus 7 times 4. And so if you did that, that would be minus 15 minus 28, and that would be minus 43. So that would be what goes down in the denominator. And so what goes up in the numerator is what the book calls the dx. So this determinant would be, instead of the 3, 7, you replace it with the, this is supposed to be, you would replace it with 1 and 3. So what ends up happening here is you would have 1 and 3, and then you keep the 4 and the minus 5. So what would be this determinant? So this would be 1 times minus 5 minus 3 times 3 times 4. So this would be minus 5 and minus 12. So that would be minus 17. So when you do this calculation, the x is the dx over d, and that would be minus 17 over minus 43. And you could see that the two minuses cancel and you get 17 over 43. Whew. See what I mean? And I purposely picked one with some crazy fractions because if you solve this any other way, it's really very tedious. And you think this is tedious, it's much more tedious to do the non-Cramer rule way. So what would be d of y? Well, this would be the determinant where you keep the 3 and 7, but you replace the answer with the y. And so if you got that, that would be 3 times 3 minus 1 times 7. And it looks like that would be the answer of 2. And so the y would be dy over d. And so that would be 2 over minus 43. And so you could see that here you get minus 2 over 43. And so a big advantage of solving these types of equations when you end up with weird fractions like this. If you try to do this using elimination or substitution, you'll see that you end up making it much easier to have a more simple arithmetic mistake with regards to that. So just to reiterate, here is Cramer's rule from the slide. And so this is slide 10, and I believe this came right out of the book. So that's where the D is the coefficient matrix. The dx is the matrix where you replace the x column with the answers. And the dy is that you replace the y column with the answers. So let's do one more example of a 2 by 2. And so here is it here. Okay, so let's set this up. So the D determinant is the coefficient. And so the x coefficients are 3 and 6. The y coefficients are minus 2 and 1. So when you do this, this would be 3 times 1 minus 6 times minus 2. And so that would be 3 plus 12, and it looks like that would be 15. So again, that's what we're going to put down in the denominator. So what is the dx determinant? And so we replace the first column, the x column, with the answers, 4 and 13. And that would be minus 2 and 1. So you do this calculation, it's 4 times 1 minus 2 times 13. Whoops, minus 2. Forgot my minus in there. So this would be 4 plus 26, and that would be 30. So you see that the x is dx over d. And so that would be 30 over 15. And that would be x equals 2. So here the elimination technique would be a lot easier when you end up with integers. And you see that the y, we keep the x and we get rid of the y with the answers. So you get 6 times 4, which is 24, minus 3 times 13, which is 39. So 24 minus 39 is minus 15. And I put it on pause because guess what? I did this backwards. And it's like, it doesn't match my notes. All right, let's start this one over. So let's rewind this one. So I had 3 and 13 goes first, right? Because here's our main diagonal. And then you subtract the off diagonal. And so that would be 39 minus 24. So instead of minus 15, the actual answer is plus 15. So the y is dy over d. And so that would be 15 over 15. And that would be the number 1. So this is an introduction to determinants. We started with a 2x2 matrix, and we introduced Cramers rule. And so the next thing we're going to do is to show you how to do it with a 3x3 matrix.